Good morning. Today we're going to work on the Unit 4 Review A, and mine starts on page 138. There might be two of them in your course pack, so I'm going to do the one that's on page 138. Share my screen here. And the first section is some short answer questions. So it says, in any experiment, the set of all possible outcomes is called the, and that would be our sample space. When an event can't possibly occur, its probability is 0. When an event is certain to occur, the probability is 1. Which of the numbers that follow could represent a probability? So remember what we learned, probabilities can be between 0 and 1. So this is between 0 and 1. This is between 0 and 1. This is more than 1, so it cannot. 6% is the same as 0.06, so it can be, and we cannot have a negative. If a die is rolled one time, find the probability of getting a number greater than 2. So rolling a die, my sample space is going to be 1, 2, 3, 4, 5, and 6. So I have 6 possible answers. And I'm talking about getting a number greater than 2. So probably that X is greater than 2. So I cannot include 2. So that would have to be 3, 4, 5, and 6. So that would be 4 out of 6, or 2/3. If a die is rolled one time, find the probability of getting a number less than 4 or an even number. So less than 4, probably of less than 4 or even. Okay. So less than 4 would be 1, 2, and 3, or even. So 2 has already been chosen, but 4 and 6 would also satisfy because it's an or. So either of these can happen. So less than 4 would be 1, 2, and 3, or even. 2 has already been counted, so it can't be counted again. So there are 5 ways for that to happen. Next is, a box contains 5 blue, 8 green, and 3 yellow marbles. If a marble is selected at random, what is the probability that it is green? So there are 8 green, and there are total in the box 5 plus 8 plus 3. So there are 16. So the probability of getting a green is 8 out of 16, or 1/2. In a classroom, the students are 9 boys and 4 girls. If one student is selected at random, find the probability that the student is a girl. So the probability that X is equal to girl. And there are 4 girls out of the 13 students. So that is the probability. Okay, let's move to the next page. We're going to talk about some sampling here. So it says you plan to sample members of exercise facilities in your city. Identify which of these types of sampling is used by indicating the correct number in the blank. We're going to circle the correct sampling. You obtain a list of all 15 facilities in your city, which you number from 0, 1 to 15. Using random numbers, you choose 3 of the facilities and interview all the members in each facility. So even though we're using random numbers, we're randomly choosing 3 of the facilities, and we're going to interview all of the members in those facilities. So that's going to be cluster sampling because we chose 3 randomly and we're interviewing all of them. Next says, you obtain a list of all the members of all 15 exercise facilities and randomly choose 400 members to interview. That would be random sampling. Number 10 says, you obtain a list of all the members of all 15 exercise facilities and put them in alphabetical order. You select every 50th member to interview. So every 50th says that we're doing a systematic sampling. 11 says, you obtain a list of all the members of all 15 exercise facilities. You compile all the names into a master list and identify the age of each member as 18 to 25, 26 to 35, 36 to 45, 46 to 55, 55 plus. You randomly select 100 members from each of the age groups and interview them. And this would be called stratified because you're taking a little bit from each group. Okay, next up, we're going to look at a STEM and leaf plot and answer some questions. So it says, as an experiment in botany class, plants are placed in a greenhouse and their growth in centimeters after 25 days is recorded, with the results shown below in the STEM and leaf plot. And these are my stems and these are my leaves, and they are measured in centimeters. So this one right here means that there was a plant that measured 13 centimeters. So how many plants grew to 25 centimeters? So there, this is the 20s, and there's one that's 5, so there's one of them. How many plants grew to 36 centimeters? So I'm going to the 30s, and there are 2 6s here, so that means there were 2 plants that grew to 36 centimeters. How many plants had their growth measured and recorded? So in this case, I'm counting all of the leaves because each leaf represents a plant. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. What was the largest growth recorded for any plant? So it looks like we had some plants in the 50s, and I'm going all the way to the end, and it looks like there were 2 plants that measured 59 centimeters. 59 centimeters. Excuse me today. Okay. Let's move on to question 13. So question 13 says, a bookstore recorded the type of books 30 customers purchased during a weekend sale. R is for romance novel, S is for science fiction, N is for nonfiction, C is for children's fiction. Construct a frequency distribution for the data. So this is a great time I wanted to bring up. On the worksheet for 4-5, I asked you to take the stem and leaf data, the raw data, actually, you made a stem and leaf plot. Then I asked you to create a frequency distribution and then a histogram. I wanted you to create both the frequency distribution and the histogram. So it's important that you're reading and completing all of the pieces to the problem. This one is just constructing a frequency distribution. So I'm listing the genres, which are R, S, N, and C, and I'm going to count how many of each. So I'm going to count the R's. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 R's. And remember, there should be a total of 30. They told us there were 30 customers. The S's, let's count those. So there's 1, 2, 3, 4, 5, 6 S's. Now the N's. 1, 2, 3, 4, 5, and C. 1, 2, 3, 4, 5, 6, 7, 8. And we have 19 plus 11 is 30. Number 14 says the grades on a college math exam are shown below. Construct a stem and leaf plot for the data. So I'm going to kind of go through and just look at where my smallest leaf is. It looks like I have some numbers in the 50s, look to be the lowest, and the highest are in the 90s. So I'm going to start my stems. And my key is going to be for, that is going to represent a 50. on the exam. So I'm going to have stems and leaves. And so I'm going to have some 50s, 60s, 70s, 80s, and 90s. And also remember that I have to have every stem in between the top and the bottom, even if I don't have any observations in there. Now it looks like I do have some in all 50s, 60s, 70s, 80s, and 90s. But on the worksheet, again, on that worksheet 4.5, the twos did not have a stem. There were exams, and I think the lowest exam score was a 14. And then there weren't any students in the 20s, and then there were some in the 30s. But you have to mark a stem for that too, to represent that there was a possibility there, but there just weren't any leaves to represent. Okay, so I've got a 50 and a 50. And I'm just going to look for any other students that scored in the 50s. No. Okay, and I'm trying to keep them smallest to largest. Okay, and then there's a 65. And that's the only 60. So I'm going to just put the 5 there. And then the 70s, I do have a 70 is 70 itself. And I'm going to look and see if there's any other 70s. No. And then it looks like I've got 2 71s. And then I've got a 73 here. Now, ideally, you're going to go the smallest to the largest within each stem, but it's not the end of the world if you get a couple mixed up. But it's nice for the reader to be able to walk up and say, oh, the smallest in the 70s was a 70. So we've got some 70s here, but I'm looking to see if there's any 76, 76. So there's 2 76. 76 and 76. And then there's a 77. And it looks like there's 2 79s. It's got 79, 79. Okay. Then I do see an 80. And then we've got an 83 here, an 84. Another 83. So it looks like 2 83s. And I said an 84. And then, so everything's down here is covered. 87 looks like to be the next. So an 87, an 88, an 89. 90, 92, 295, and then 99. So there's our summary plot. Okay, let's take a look at question 15. Question 15 says, the data shows hours spent at work for a group of men. Find the mean, median, mode, mid-range, and standard deviation for the data provided. So I'm going to first do the ones that I can't use Desmos for. So I can use Desmos for mean, median, and the standard deviation. The mode is counting up the number of men that have the exact same hours that they worked. So it doesn't look like I had any that had the exact same hours. So there is none available. There is not a mode. And the mid-range is your high plus low divided by 2. So the lowest number of hours worked looks like to be 29.1. Plus the largest is 64.3. And so we can go ahead and get out our calculator here. And we've got 29.1 plus 64.3 divided by 2. is the mid-range is 46.7. Okay, now I'm going to take you to Desmos and we are going to put that in. And let me share my screen here with y'all. And so I'm going to do, first have to put in our data so that we can tell it what column. And so we have 64.3, 58.3, 56.9, 45.7, 43.3, 48.7, 35.9, 20.1. Okay, then I'm going to go down here for the mean. I'm going to type mean parentheses x1 parentheses. The median is just MEDI, median parentheses x1. And then my standard deviation, because this is just a sample of men, I'm not going to do the population. I'm just going to do STDEV parentheses x1. Okay. So there is my mean, my median, and my standard deviation. So my mean is 46.675 hours. My median is 44.5. And my standard deviation is 12.196. So about 12.2. Okay. So I'm going to go back and show you my paper, how I wrote it all on the page. And my mean, I want to show you the symbols again. So the mean, because you're finishing up your project probably right now too. And in the project for Unit 4, I did ask you for the symbols for the sample versus the population. So the sample mean is going to be X bar. And because this is a sample, my standard deviation is an S, okay? It says, which would be the best measure of central tendency and why? So the central tendency, I'm looking at the mean, the median, the mode, and the mid-range. And the mode, there isn't one, so that's definitely not going to be a good measure. The mid-range is close to the mean. But remember in the lesson, I said that it's always good to compare your mean on the left and your median on the right. And your mean is 46.68, we'll say, and the median is 44.5. And it looks like your mean is larger than your median. And you can decide if that is, if you feel that that's a lot, then you can say it's skewed to the right. Or if you think it's they're approximately equal, you can say that they are symmetric. And if you think that it's skewed to the right, so this is kind of a call on the scientist, on the statistician here. If the skewed greater than says it's skewed to the right, means that this 64.3 is an abnormally large value compared to the rest. That's what that would kind of be saying, which is only 6 points higher than 58. But you can see that this 29.1 is 6 points lower than the 35.1. So, you know, with this being only two values apart, I might say that it's symmetric. If you say it's skewed right, then you're going to choose the median. So this is where you just have to, when you give me a Y, you have to say, if you're choosing the median, you have to tell me that you believe it's skewed right. If you tell me that it's that you're going to choose the mean as your best measure of center, then you need to tell me it's because you think that the data is symmetric. Okay, that's kind of what I'm looking for there. Let's move on to the next page here, question 16. At the top of page 141. It says, these data represent the grades on a college exam. Find the mean. Okay. So because I don't have the raw data, so let's just write, I don't have raw data, right? The actual data. I just know that 3 3 students scored it between 60 and 69. Let's say original data. I have to use a weighted average. So we have to have midpoints. Okay, my midpoints are going to represent my different class limits. Now, we did a couple different ways of finding your midpoint. I'm going to use the average between 50 and 60. I think in our course book, they use the average between 50 and 59. So let's just go with that. We're going to do the average of 50 and 59. So if I add 50 plus 59 and divide by 2, my midpoint would be 54.5 here. And my width, they're increasing by tens. So that means my next midpoint should increase by 10 to be 64.5, 74.5, 84.5, and 94.5. We're going to put our midpoints in X1, and then we're going to put our frequencies in Y1, okay? And then we're going to do the total of X1 star Y1 divided by the total of Y1. Okay, this is how we do the weighted average in Desmos. So let's go ahead and go to Desmos and put our data in and work on this. Okay, so you can see here in Desmos, I put my data in, and my mine are labeled X2 and Y2 because I already have that data set up here from before. Okay, so whatever your data are labeled, that's what you're going to use in your calculation. So I'm going to type total, and I'm going to put that in parentheses because I want to make a fraction here. So I'm doing the total of X2 star Y2 parentheses divided by the total of Y2. Okay, now remember, you're going to go by what your columns say, X2, Y2, X1, Y1. And it looks like my weighted mean is 80.7%. 78, so we'll round it to 80.8%. Okay. So I would like to show you my paper here for a moment. And this is where I got 80.8%. Now, had I done my midpoints, what I mentioned earlier, the 50 plus 60 divided by 2, I would have come up with 55, 65, 75, 85, 95. And that's okay, as long as you're showing me the midpoints that you're choosing or saving your Desmos work for the final, you can send that to me. My mean would have been 81.3. So notice they're a little bit off. And that's why we have to say that this mean, this weighted average, is an estimate because we don't have the real data. We don't know the actual mean. Okay, that's something important to think about. Okay, let's look at a few more of these, and there will be a second part to this review. So to finish up part 1 here. So it says, Helga scored in the 70th percentile rank on an exam. If 300 students took the exam, how many students scored lower than Helga? So 70th percentile, 70th percentile means that Helga scored higher than 70% of this class. We don't know what her score was, but the 70th percentile tells us that she scored higher than 70% of the other students. How many students scored lower than Helga? So that would be 70% of them. So 70% of 300 equals 0.70 times 300 And that should be 210 students. Okay. Number 18 says, which data set would be likely to have the larger standard deviation? Explain. Data set 1 is weights of all dogs at a golden retriever rescue shelter. And data set 2 is going to be weights of all dogs for sale in a pet store. So a larger standard deviation means which group are probably not going to be as similar to each other. So the weights of all dogs at a golden retriever rescue are probably all going to be similar to each other because they're the same type of breed. And so the weights of all dogs for sale in the pet store, you can have really small dogs and really large dogs. So the one with the larger standard deviation would be data set 2. Okay. Question 19. It says a professor has 2 sections of Math 115 this semester. The 8:30 a.m. class has a mean score of 72% with a standard deviation of 3.2. The 2 p.m. class also has a mean score of 72%, but a standard deviation of 18.2. What can we conclude about the students' averages in these 2 sections? Okay, so the morning class, they have the same mean. They have the same class average. But, excuse me, the morning class has a much lower standard deviation. The 8:30 a.m. class has a much lower standard deviation. And so we can say that they are more centered around 72%, the average. So that morning class with that small standard deviation, we can say that they all scored probably pretty close to that 72%. The afternoon class, their average was 72, but to have such a high standard deviation of 18.2% tells us that there was probably some really low scores and some really high scores, and they kind of settled in the middle at 72%. Okay, we have just a few problems left, and we are going to reserve those for the second part of Unit 2 or Unit 4 review. So I will see you back for problems 20 through 24 on Unit Review A.